Okay, it's 12 now, so I will start with the introduction and maybe some people will join later, but so we can start in time. I will already go ahead. Well, welcome everyone to our ECOP Wednesday webinar. Welcome back after a break in June. I will moderate this session and I will briefly go over some housekeeping rules. So please make sure that your name is clearly entered. We ask you to keep your microphone muted unless you want to ask a question. And before you speak, please raise your hand. And you can also put your questions in the chat and then I will ask them later during the Q&A. Please be respectful and use appropriate language. And if you want to stay in contact, we do have a Slack channel if you're interested in that. So on the ECOP network, we are for early career ocean professionals at EMB member organizations. And this network has been established by the EMB Young Ambassadors and the Secretariat. We want to give young researchers or early career ocean professionals the opportunity to network and meet peers across Europe and also to gain a voice at the European Marine Board. And for this, we have these ECOP Wednesdays series, and then also we start the ECOP Network Forum this year in October. And today our speaker is very special to us because he's one of our young ambassadors. It's Riwan Leroux from Ifremer in France, and he got his PhD in Canada and is now working at Ifremer in France on deep sea projects. And there he wants to give us a talk from a research project to a policy management to pressures in the deep sea area and marine protected areas. So we're very excited to hear about Riwan's work in the deep sea. And I will stop sharing my slides so he can go ahead.
Hello, everybody. So I will present my project. So let me share my screen and just switch. Okay, do you see the presentation mode?
Yes, looks great.
Okay, perfect. So I will talk to you about my project. I began at Ifremer, and I will focus on how my project is a management tool and how I reach some policy aspects with my project. So I will talk you a little bit more about my project at the first place, and then we will see how it can be involved in policy and management tools. So I'm studying the pressures, the anthropogenic pressures in the deep sea, and more precisely in hydrothermal vent systems. And I focused my study area into marine protected area in the Azores. So I aim to create impact indicators in the deep sea to provide some recommendation for management and policy rules. So I kind of gather the science, the management, and the policy making. So as I said, my location, the location of my study area is in the Azores MPA, so at the Lucky Strike vein field, which is in the Mid-Atlantic ridge. And in this Lucky Strike vein field, we have several hydrothermal vents, which you can see in the black dots. Around 1,700 meters depth. And we went to this hydrothermal vent field for like 30 years. And we did a lot of research studies and activities. And we implemented also an observatory deep observatory, which is called EMB Azores, in 2010. So for 13 years. And all these activities for the past 30 years bring a lot of pressures into the environment. So I aim to map and evaluate the intensity of the scientific activities in the Venn field over the past 3 decades, and then assess if the research activities have an effect on the ecosystem, and propose indicators to be implemented into the management plans and the piece of legislation the government is writing now for this MPA and for protecting the bottom of the MPA. So among the different research activities, we have different harmful pressures. First, the direct pressures, for example, the sampling. So in the photos, you can see the ROV, so the robotic submersible, which is sampling the different community to studying it. So to get more clues about the biodiversity, the ecosystem functioning, or the physiology of the different organisms. So for the sampling, we can use the suction sampler or the mechanical arm. And usually we remove a lot of organisms to have samples and to study them. We can also make some moorings or measurements, which are kind of the same things, but the measurements are just like temperature measurements, sulfur measurements. But the moorings are like measurements, but during 1 year round, to see the temporal evolution of the different variables we are interested in. We have also the indirect pressures with the different piece of liter, because when we bring the observatory in 2010, it involved a lot of liter deposition, dead weight, and stuff like that. So, for example, in the bottom left picture, you can see shot bags. So it is a bag full of iron beds we use to weight the different instrumentation. For example, the station you can see in the top left, which contains a lot of instruments, and it is deployed at the 1,700 meters depth with dead weights to go down, and then we just cut the weight to lift the station up. On the top right, you can see also the buoy. We used to transmit our information between the field and the shore. And at the bottom right, you can see the elevator or the shuttle we use to provide more instruments to the submersibles and avoid the submersible to go up. So each of these instruments requires also dead weight, so 500 kilos of iron chains. So with the basic counting, we have accumulated about 140 tons of metal liter, and also some other plastic liters, since we have to use like tie wraps or stuff like that, and we just leave them into the bottom. So we have that, and the indirect pressures. We have also the light and noise from the submersible. Since the hydrothermal vents are in a dark place, in black place, the organisms are not used to the lights, and the light can have important impacts on the physiology of different organisms. For example, we found that some vent shrimps can be blinded by the lights permanently. So it's a kind of strong pressure on the ecosystems. And with the noise, we also know that some organisms use the noise and the waves to get some direction and to orientate themselves. So we look at all these activities to estimate if we have strong pressures in the bottom, and to then study the actual disturbance of the ecosystem these pressures could have. So to do that, we have to weight all these pressures, and it's difficult because we don't have so much clues, and we have to use different methods or unusual methods to weight these pressures. So I decided to implement the Delphi method to weight these different pressures and different research activities. And to do that, we just made a questionnaire to ask researchers, deep sea researchers, to weight the different pressures based on the impact they think they should have into the ecosystem. So, for example, you can see here a graph with the preliminary result of this Delphi, where we can see that beyond the index of 2, we have substantial effects, and you can see that 4 or 5 pressure items are above these limits. For example, the trash or the sampling with the submersible arm. And all these weightings will allow us to have an integrated index to estimate the different impacts from the research activities into the liquid strike vent field. So you can see here, for the people who work in the deep sea, you can see here the QR code for the form. And if you want to participate into the evaluation of the impacts, please flash it and answer the form. So once we have these different index, the idea is to integrate them. So, for example, we have light, noise, different measurements, different samplings, last, trash, moorings. We can map them and integrate them with the weighting of the Delphi to have a final map with the cumulative pressures. So, for example, here you can see a zoom in the hydrothermal, the liquid strike hydrothermal vent field. Sorry. So again, it's preliminary results, but you can see in these vent sites that you have a lot of research activities near the sites themselves. But in the peripheral area, you have less cumulative pressure, since science is less interested in the peripheral area of the hydrothermal vent field for now, but it is changing a little bit. And so to make a short story, we have the pressures. We want to integrate them with a rating of the potential impacts of these pressures, but we have to take into account that we have some pressures who are occurring again and again. For example, in the liquid strike vent field, since we come back every year for the past 30 years, at the same place, you can have several hundreds of hours of illumination, for example, dozens of samplings. So we have to take that into account to have a more integrated spatial temporal estimation of the impacts of the research activities. So we have to build the interval ratings, and then you can finally have the cumulative pressures, which take into account the different hours of light, the different numbers of samplings, liter, moorings. And the idea then is to build the integrated research pressure index. So it's an index I just named. But if it works, it will be able to gather all information into one map with one index per pixel to tell the management or the governments, okay, here in this pixel, you have a lot of research activities, at least a lot of pressures, and we expect a lot of disturbance. So maybe you should avoid to authorize other research activities into this pixel of MPA. So this is the idea. So, for example, with the preliminary mapping of the index, you can see here it was in the center of the graph. So this is a map of the Lucky Strike Van field. In colors, you have the yellow, the least impacted, and the blue, the dark blue is most impacted areas in the Van field. And you can see in the center of the map the two blue dots, which were the zoom I presented you earlier. And what is interesting is that these two sites, so Tour Eiffel, Eiffel Tower, or Montségur, are two well-studied sites. And it's interesting because we have a time series and stuff like that. But you can see that maybe it's not clever to go on with these sites, and maybe we should focus on other sites because the pressures tend to accumulate in these areas, and we don't know yet the impact these pressures could have into the ecosystem. So once we have these maps, the goal is to study the impacts directly on the community by imagery. So we will retrieve some videos back into the 90s and see with the new videos if we have an impact, for example, a loss of biodiversity, a loss of abundance, or difference in the complexity of the habitat, stuff like that. So this is for the project part, and so you can probably see how it can be useful for the management and the policymakers, but it's not so easy to get the policymakers involved. But I have the chance to work with the Ifremer, which is implemented the observatory in the Azores, and they have a longer term relationship with the governments there. So for reaching the policymakers and the managers, we have like 3 steps. First, we have to share the results. And in my project, we have to share them before the publication, of course, because they are writing the piece of legislation for regulating the activities into the MPA right now, and they have to hand it by the end of the year. So my postdoc will last 3 years, so I have to be quick, and more quick than I expected. So I share my results, my maps, and stuff like that right now. I have also to inform the stakeholders. So in my case, the stakeholders, so the people who get impacted by the decision of the MPA management are mostly the researchers. So this is actually the Delphi form I send them to explain my project and to ask them to participate into the weighting of the different pressures. And then we have to engage with policymakers. So for the first part, with the scientific community, it was easy to engage because it's my domain, and my supervisors have the connections. It's also useful to publicize the project, and get leverage and access. For example, with the Deep Rest project, we have a lot of we are involved in a lot of policy link projects. I also joined the European Marine Board as a young ambassador to promote this kind of project and to get a wider view of the marine policy and management. To engage with the stakeholders, so it was also the scientific community, since they are most concerned about the legislation. So, for example, I reached the DOSIS, or Deep Ocean Stewardship Initiative, and the Deep Sea Biology Society. But I also try to get to the Azorians people, because they are much concerned for the use of their waters and their MPA, and that's what I call the decolonization of the science, because France has been involved into the study of the Location Vent field for the past 30 years, and we just it took time to understand that we had to share the results with the Portuguese and the Azorians in particular, because they knew that we did research there, but they didn't know how and what were the results. So we began to organize some side events like Pint of Science or exhibitions, stuff like that. And actually they will begin this summer. So it's really important to have this in mind, because maybe they don't have the means to reach their deep sea environments, but we have, and then we have to share. And finally, about the policymaking part, I engage with the Azores governments. So first by sharing maps and sharing the results, and have some talks with them. But my role will go further than that. So we are talking about making some synthetic reports. I will maybe participate into the elaboration of the piece of legislation they plan to implement into the Azores MPA. So just it is just a way to get involved and to share the science, and to get some political aspects from your research into more policy-friendly, into more policy ruling. So it is important because it's why we do science. It's for informing the society, and since we are able to give some advice and to have some expertise, we should get involved. And actually, it's kind of intimidating at first, because you just have to meet with some government representatives and officials. But actually, it's really easy, and the people are just eager to learn more and to better understand what they have to rule about. So it is really easy steps to get involved and to make our science more impactful and more applied. So it was yeah, that's it. It's about my project and the way I want to involve into more policy aspects. So thank you. So we have kind of a lot of time to talk. If you have some questions, if you have some suggestions, if you want to see my QR code back, please tell me.